Every now and then, we use things so frequently, so instinctively, that we stop noticing them altogether. Take a look around right now. Whether you're inside a house, walking through a city, or watching this on a screen from your phone, there's a very high chance that aluminum is playing a silent but essential role somewhere close by. It's in the structure of airplanes soaring above our heads, in the cars we drive every day, in the long, endless power lines that bring electricity to our homes. It wraps our food, frames our windows, and forms the skeletons of our laptops. Yet despite being so omnipresent, most of us know shockingly little about where aluminum actually comes from, or how it goes from being an unremarkable rock buried in the earth to becoming one of the most prized metals on the planet. The numbers alone are staggering. Every single day, across the globe, close to 200,000 metric tons of aluminum are produced. That's not just a statistic. It's a reflection of a world powered by this incredible material. In the United States alone, the annual consumption surpasses 4.6 billion kilograms, a figure so large it's almost hard to visualize. Imagine mountains of metal being transformed into planes, skyscrapers, electrical infrastructure, consumer electronics, and even the packaging that keeps your favorite drinks cold. To keep up with such overwhelming demand, we need to process millions of tons of raw material extracted from the Earth's crust. And that's where our journey begins. It starts not with something shiny or futuristic, but rather with something ancient and earthy. A red, coarse rock known as bauxite. Found in abundant quantities in tropical and subtropical regions, bauxite is the primary source of aluminum worldwide. It might not look like much at first glance. It's dull, heavy, and stained with iron oxides that give it that characteristic rust-red color. But hidden inside this rock is a compound known as aluminum oxide, and within that compound lies the key to extracting aluminum itself. So how do we take this rugged, seemingly lifeless stone and refine it into the sleek, lightweight metal that defines our modern age? The process is long, precise, and deeply rooted in the history of science and industrial innovation. It begins with mining. Giant machines, excavators, bulldozers, and loaders dig deep into the earth, scooping up tons of bauxite from open-pit mines. These sites often stretch across vast landscapes, where red dust clings to everything in sight, and the air hums with the sound of industry. Once extracted, the bauxite is transported, often over great distances, to industrial refineries, where the real magic begins. But before we go deeper into the modern process, it's worth pausing and asking, when did humanity even realize that something valuable lay within this common rock? The answer takes us back over 2 centuries, to the early 1800s. In 1807, a British chemist named Humphrey Davy made a groundbreaking observation. He was studying a substance called alumin, a salt known since ancient times and used for everything from dyeing cloth to medicinal purposes. While examining alumin, Davy theorized that a new kind of metal might be locked within its structure. He even proposed a name for it, aluminum, though at one point he also used alumium, and British spelling would later settle on aluminium. Identifying it, however, was only the first step. Isolating pure aluminum from the substances that contained it turned out to be an incredibly difficult task. For years, aluminum remained an elusive substance. Scientists knew it existed, but they couldn't figure out how to extract it in its metallic form. This challenge made aluminum more valuable than gold during the early 19th century. In fact, in the 1850s, Napoleon III of France had a set of aluminum cutlery reserved only for honored guests, while lesser visitors had to settle for gold. That's how precious and rare aluminum was at the time. It wasn't until the late 1800s that the breakthrough finally came. In 1886, two young men, Charles Martin Hall in the United States and Paul Héroult in France, independently discovered an electrochemical process that could extract aluminum from aluminum oxide using electricity. This process, now known as the Hall-Héroult process, revolutionized the industry. Overnight, aluminum went from being an exotic laboratory curiosity to a material that could be produced on a large scale. The gates to industrial-scale aluminum production had finally opened. Let's zoom back in to modern times. Today, after bauxite is mined, it goes through a process called the Bayer process, named after the Austrian chemist Carl Joseph Bayer, who developed it in 1888. This process involves crushing the bauxite and mixing it with a hot solution of sodium hydroxide. Under high temperature and pressure, the aluminum oxide in the bauxite dissolves into the solution, separating it from the impurities like iron oxides and silica. What remains is a white powdery substance called alumina, pure aluminum oxide, which is the direct precursor to metallic aluminum. But we're not done yet. The alumina must then undergo the Hall-Héroult process, where it is dissolved in molten cryolite and subjected to massive electrical currents. This is where the metal is truly born. As the electricity passes through the molten mixture, it causes the aluminum ions to separate from the oxygen, forming pools of pure, molten aluminum that sink to the bottom of the electrolysis cell. This glowing, silvery liquid is then collected, cooled, and cast into blocks, ingots, or rolled into sheets depending on its intended use. From here, the aluminum is sent out into the world, ready to be molded into cars, aircraft, computers, beverage cans, and just about anything else you can imagine. Aluminum is more than just useful. It's a metal with extraordinary properties. It's about 3 times lighter than steel, yet offers a surprising degree of strength. This combination of low density and high resistance has made it the go-to material in the aerospace industry, where every kilogram counts. Unlike iron, which rusts and decays over time, aluminum forms a thin layer of aluminum oxide on its surface when exposed to air. This layer acts like a shield, protecting the metal from corrosion and making it ideal for outdoor and marine environments. It's no wonder that once scientists figured out how to extract and manipulate it, aluminum rapidly took over industries that needed durability, flexibility, and efficiency. Yet what makes aluminum truly remarkable isn't just its physical characteristics, it's the story behind its production. The human effort required to identify, extract, and refine this metal speaks to our relentless curiosity and ingenuity. Think of the generations of scientists who worked to isolate it, the engineers who designed better and better systems for processing it, the laborers who dig for bauxite under a blazing sun, the operators who run the electrolytic cells in enormous humming factories. Each piece of aluminum in our world carries with it a legacy of discovery, labor, and transformation. And this story doesn't end here. The aluminum industry continues to evolve, especially as sustainability becomes more critical. Because aluminum doesn't lose its properties when recycled, it can be reused indefinitely. Today, a growing percentage of global aluminum production comes from recycling, not just because it's cheaper and more efficient, but because it's essential for reducing our environmental footprint. In fact, recycling aluminum uses only about 5% of the energy required to produce new aluminum from bauxite. That's why aluminum cans, for example, are one of the most recycled products in the world. So the next time you crack open a soda, fasten your seatbelt, or open your laptop, remember, what you're touching isn't just a piece of metal. It's the result of a centuries-long journey, a triumph of science and industry, and a testament to the brilliance of human creativity. It took more than 2 decades after the first spark of discovery for humanity to take its next major step toward unlocking the true potential of aluminum. In the early 19th century, the Danish chemist Hans Christian Ørsted finally succeeded in isolating this elusive metal. His achievement was monumental. He had done what others had only theorized. But even though the scientific breakthrough had arrived, the practical reality was still far from reach. Extracting aluminum remained an excruciatingly complex and prohibitively expensive process. So difficult, in fact, that by the time the 20th century approached, aluminum had earned the title of precious metal. And it wasn't just a nickname, it was quite literally more valuable than gold. In the palaces of emperors, this strange, lightweight metal was a symbol of prestige. It was not uncommon for powerful figures to flaunt aluminum as a display of modernity and wealth. Napoleon I, for instance, reserved his prized aluminum cutlery for the most distinguished of his guests, while the less fortunate had to make do with utensils made of mere gold. That's how rare